Hello there, welcome back to another video. And guys, in this video we are gonna start coding our multi-layer perceptron. So let's take a look at our uh, architecture of the multi-layer perceptron that we are going to make. So for that, what we will have is that we will have two input neurons. After that, we will have a layer of four neurons and a layer of three neurons, and then we will have a layer of output, basically an output layer, which will have two neurons. So as let's first import some data sets so that we can use it on our MLP. So you can use from sklearn.datasets import make. uh, let's use make nodes. Okay, so from sklearn. Now what I'm going to do is I'm going to get x and y. Okay, so x and y is going to be make nodes, and let's take 500 examples. Okay, so n samples is going to be 500, and let's take noise as 0.2. You can experiment with all of these, and let's set random state to 1. Okay, now let's scatter our plot, or let's scatter our data. So plt, I also have to import that. Import matplotlib.pyplot as plt. Now plt.scatter. In this, first we need to scatter our first 0th column, that is all example, and the 0th column. Now we need to scatter our first column. Okay, and let's set the color as pie, and yeah, let's check this first. Okay, so plt is not defined. Maybe I have to do this. So x and y must be the same size. Okay, so this should be like this, all the rows and the 0th column and the first column. Yeah, I think it should work now. So this is the data that we have. Okay, now basically if we will see our x, then we can see that we have 500 rows and 2 columns. Okay, so because we have 2 columns, that's why we have we have 2 neurons in the input layer. After that we will have 4 neurons, then 3 neurons, and for the output layer we are going to have 2 neurons. So this number will go here and this number will go here. Then for the next example, again this number will go here and this number will go here. Okay, so this is how it is gonna work out. Now let's create our neural network class. Okay, so let's make class let's say neural network. Okay, and then we need to define our constructor, or you can say the init function in this case. So in this, first we need to pass self. So let's pass the input size as going to be 2. Okay, now layers is going to be, so we will have 2 layers. In the first layer we will have 4, and in the second layer we will have 3. Okay, then the output is going to have 2 neurons again. Okay, now let's set the random seed np.random.c as 0, and you can set it as you like, but I'm setting it as 0. Also I have to import numpy as np. Okay, and if you can if you want to, according to your data, you can change these parts, and according to that it is going to work anyway. But you but if you have like more than 2 layers, then you have to change some other parts in the code too. I will explain that later, but for right now, just focus on this part. Okay, so we are going to make a model, and that model I am creating it as a dictionary. Okay, so for the model we will have our weight w1. Okay, so we will have our weight. Let me just show you. 1 2. So this is going to be our weight 1, and here we will also have v1. Okay, now for this case, this is going to be our weight 2 and v2 bias 2. Now for this case, we will have our weight 3 and bias 3. So we can start them as 0. We can have all the values as 0, it does not matter, but it is good to initialize it at some random numbers. So okay, so now for that, what we need to do is we need to make np.random.randn. Now in this what we need to do is we need to pass the size of the weights that we need. So in the input layer we have 2 neurons, and in the first hidden layer we have 4 neurons. So the output of this of w here is going to be 2 by 4. Okay, so this is going to be the size of this weight matrix. Now I have explained everything, like why this will be the output in previous video, so please go and check that out. So here what we need to do is input size and layers 0. So this is the size that we will need. Okay, now for the bias 1, so model b1 is going to be np dot in this case let's use zeros. So you can use zeros, and or you can use anything else like random number here also. It does not matter that much, because you are going to use back propagation to correct these numbers by themselves, so you can set them like this. So in this case I am using zeros. Okay, so let's we need one column. Okay, and then the size should be layers 0. So why it is that we need only one column? Because so for every neuron we will have one p. Okay, so if you will put it in the form of the matrix, so you can say that we will have only one row, and we will have this number of what do we say, columns. So this is going to be b, let's suppose this is b0, b1, b2, b3, b0, b1, b2, b3. So the shape of this is nothing but 1 by 4. So that's what we are doing here. Now what we need to do is we need to make similarly we need to change it for our so now what we need to do is we need to change it for our second weight and the third weight. So like this. Let's copy it once more. So this is going to be weight 2 bias 2 and weight 3 bias 3. Okay, now we need to change some we need to make some changes here. For the second weight matrix, what we need is layers 0 to layers 1. Okay, and here what we need is layers 1. Okay, and for this part what we need is layers 1 and output. I hope that it is clear, but like, let me explain once more. But from now on I'm not going to explain these things again and again, because I have already explained them in my previous videos, so please go and check them out. Let's take the example of the second layer. Okay, so this was our first input layer, then this was our first hidden layer, this was our second hidden layer. Okay, now we need to make weight matrix for this. So the weight matrix for this is going to be 4 by 3. So as you can see here, we have layer 0. Layer 0 is going to be 4, and then we have layers 1, so it is going to be 3. So it is going to be 4 3 4 3. Okay, similarly we have 1 and layers 1, because we will have only one row here and 3 columns here. Now let's do it for the last layer, the bias for the last layer. Okay, so this is going to be nothing but 1 and output. So this is our neural network. This is the basic architecture of our neural network. Okay, so now what I'm going to do is self.model equal to model. Okay, so it is saying that it has some problem, invalid syntax. So self.model equal to model. Let me check this out. Oh yeah, I need to have one more close bracket here. It should be fine now here.